Well, hey everybody, I hope you enjoyed class the other day. The pictures on this screen should remind you of some of the things that we did in class. Let's start with the picture in the upper left-hand corner where you took that little piece of paper and you blew across the top of it. So as you were blowing across the top this way, you created an area of low pressure. So the higher pressure was down below, and the higher pressure always wants to go to where there's a lower pressure. Remember that phrase that we had? Things want to move from higher concentration to lower concentration. So now the high pressure air wants to go up, but the paper's in the way, so it's blowing up or pushing up on the paper. Okay, look at the one in the upper right hand corner. With that one, we had two cans and we created a low pressure area right between the two cans. So that's where the low was. The higher pressure on the outside wanted to get to where the lower pressure was. The cans are in the way, so they pull, or I shouldn't say pull, they push those two cans together. Let's look at the one down here in the bottom where we have the funnel and the ping pong ball. So as the air is coming through this funnel opening down here, it's coming up around the ball this way, only on the inside of the funnel. It's coming around the ball this way, and that makes two areas of low pressure. So the air on the outside is higher pressure. It wants to get in there, but it can't because the ball's in the way, so it holds the ball in the funnel. Hopefully in your science notebooks you have diagrams of all of these that we did in class the other day, and you have clearly labeled where the high pressure is and where the low pressure is. So if you were to label this first one up here in the upper left hand corner again, you have an area of low pressure here, an area of high pressure here. Use the letters H and L, and then use arrows to show where the air is pushing. So in this case, the high pressure is pushing up. So go back to all the diagrams in your notebook and make sure that you have clearly labeled each one of those. So some other things that you need to write in your notebook, if you don't already have them there, are these statements. And one of them is we know that moving air has less pressure. Another way to say that is if there's an increase in velocity, that means something's moving faster, so it's going up, it's moving faster, 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 the pressure actually goes down. So when something is moving fast, the pressure goes down. That's just the opposite statement of what we have up here. So you can either remember it that moving air has less pressure, or fast air has, excuse me, as you end up increasing in speed, you're going to have a lower pressure. I guess that's not the opposite. They are exactly the same thing. Sorry about that. Okay, all of this comes together in a principle that we call Bernoulli's principle. The man it's named after was Daniel Bernoulli. He lived in the 1700s, and when you go back to the assignment page for this week, you'll see a reading that I have for you that talks a little bit about Daniel Bernoulli. I would like you to read that, take notes in your notebook, and we'll talk about him a bit when we come back together next week, and also any other questions that you might have related to the investigations that we did in class. The other thing is, if you would like to redo your 3, 2, 1 blast off test, you are welcome to do that. Just go back to that link, click on the link, and then retake the test. And what I will do is I will grade, we have the score from the first test, and I'll take a score from the second test and I'll average those two scores. Some of you would like to see if you can improve your test scores, so that's a way to do that. I'll see you in class next week. Thanks. Bye.